Have you ever looked up at the night sky and wondered, are we alone? Tonight I want to take you on an incredible journey. Not just any journey, but one that spans 60-35 light-years across the cosmos, to visit worlds that might just change everything we thought we knew about life in the universe. Picture this: a planet where a single day could last forever, where vast oceans stretch beyond the horizon, and where the very ground beneath your feet could tell stories of life forms so alien, yet so familiar, that they'd make you question what it truly means to be alive. This isn't science fiction, my friends. This is real. These worlds exist, spinning silently in the darkness, waiting for us to discover their secrets. And the most incredible part, some of them might be more like home than we ever dared to imagine. Let me tell you a story about the year 2011. While most of us were going about our daily lives here on Earth, a robotic telescope named Kepler was playing cosmic detective 94 million miles away from home. You see, Kepler had a very special job. It was staring, just staring, for years on end, watching over 150,000 stars simultaneously, waiting for something magical to happen. And then it did. Picture a lighthouse beam sweeping across the ocean. Every time a planet passes in front of its star, the starlight dims slightly, like someone briefly walking in front of that lighthouse. These tiny dips in brightness, sometimes less than 0.01%, became our windows into other worlds. When scientists first analyzed the data for Kepler-22b, teams of researchers gathered around computer screens in amazement. Here was a planet, roughly twice Earth's size, orbiting in what astronomers call the Goldilocks zone. Not too hot, not too cold, but just right for liquid water to exist. It was like finding a needle in a cosmic haystack. But here's what makes this discovery truly mind-blowing. Kepler-22b doesn't just orbit any random star. Its host star, Kepler-22, is remarkably similar to our own Sun, a yellow dwarf, about 4 billion years old, almost like looking at our Sun's older sibling. The distance? A staggering 63. To put that in perspective, if you could travel at the speed of light, the fastest possible speed in the universe, it would still take you 63.5 years to reach this world. That's like starting your journey before the invention of the printing press and arriving, well, sometime in the distant future. So what would it actually be like to visit Kepler-22b? Close your eyes for a moment and imagine stepping off your spacecraft onto this alien world. The first thing you'd notice? The gravity. At 2 or 4 times Earth's size and potentially 36 times more massive, this planet would literally try to crush you. If you weigh 150 pounds on Earth, you'd suddenly weigh 900 pounds. Walking would become nearly impossible. Even lifting your arm would feel like you're underwater, but without the buoyancy to help you. Space exploration experts tell us that nothing in human experience compares to what we'd face on Kepler-22b. Your bones would need to adapt. Your muscles would have to become incredibly strong just to function. It would be like being permanently trapped in a suit made of lead. But the challenges don't stop there. Remember how I mentioned this planet might be tidally locked? Let me paint you a picture of what that really means. Imagine if Earth suddenly stopped rotating relative to the Sun. One side would be trapped in eternal daylight, baking under constant solar radiation. The other frozen in perpetual darkness, where temperatures could plummet to unimaginable lows. And right between these two extremes lies a thin band, the Terminator Zone, where dawn and dusk exist simultaneously, forever. On the permanently lit side of Kepler-22b, life would face a unique challenge. Constant starlight means constant energy for photosynthesis, but it also means relentless heat and evaporation. Imagine oceans that never know night, where water vapor rises continuously into the atmosphere, creating massive cloud systems and potentially devastating storms. The weather patterns would be unlike anything we've ever seen on Earth. Atmospheric scientists studying similar scenarios tell us that weather on a tidally locked planet would be fascinating and terrifying. You'd have constant heat driving massive convection currents, creating storm systems that could dwarf anything we see on Earth. Hurricanes that never end, fed by an inexhaustible source of energy. Now flip to the other side, a world where the sun never rises. Here, in this realm of perpetual night, temperatures could drop so low that even the atmosphere might freeze solid. But here's the incredible part. Even in this seemingly hostile environment, life might find a way. Here on Earth, we've discovered organisms thriving in the deepest ocean trenches, where sunlight has never touched, surviving on chemical energy alone. Marine biologists have discovered some of the most fascinating life forms on our planet, existing in complete darkness. Giant tube worms, bioluminescent fish, bacteria that literally eat chemicals and produce light. If life exists on Kepler-22b's dark side, it would probably glow. Imagine entire ecosystems painted in blues, greens, and purples, creating their own alien aurora. But perhaps the most intriguing region of Kepler-22b is where these two extremes meet, the Terminator Zone. Picture standing on the boundary between eternal day and endless night, where the horizon glows with a permanent sunset that never fades. This narrow band around the planet might be where life has its best shot. Temperatures here could be stable enough for liquid water, creating rivers, lakes, maybe even seas that exist in this perpetual twilight. Astrobiologists studying such environments believe the Terminator Zone represents the ultimate compromise. You have energy from the nearby day side, but not so much that it becomes destructive. You have cooling from the night side, but not so much that everything freezes. It's nature's perfect balance. Think about it. Evolution on Earth has produced incredible diversity, but it's always been constrained by day-night cycles. What kind of life might evolve in a place where the light never changes, where the temperature remains constant for millions of years? Plants might grow in spirals, always reaching toward the day side. Animals might navigate by the glow on the horizon, developing senses we can barely imagine. Some might even migrate in great circular patterns around the planet, following the Terminator Zone like an endless, slow-motion migration. Let's imagine we found life in the Terminator Zone. What would a typical day look like for a creature here? There's no sunrise to wake up to, no sunset to signal rest. Time might be measured by other rhythms, perhaps the ebb and flow of tides caused by distant moons, or the shifting patterns of storms on the day side creating atmospheric waves that ripple into the twilight zone. Imagine creatures that have evolved internal clocks based on completely different cycles. Maybe they rest when certain chemical concentrations in the atmosphere change, or when the subtle shifts in temperature indicate changes in the distant storm system. Now let's talk about the elephant in the room, or should I say the gravity monster that would crush that elephant. Living on Kepler-22b wouldn't just be difficult, it would fundamentally change what it means to be a living creature. When physicists model high-gravity environments, they have to reimagine everything. Forget about trees as we know them, they'd collapse under their own weight. Forget about birds, flight becomes virtually impossible. Even simple things like rain would fall like bullets. But life is incredibly adaptable. Look at how different creatures on Earth have evolved to handle various pressures. Deep-sea fish can withstand crushing depths that would instantly kill surface dwellers. Maybe life on Kepler-22b has found equally creative solutions. Imagine animals that look more like living pancakes, spreading their weight across a large surface area, or creatures with internal structures so efficient, so perfectly engineered, that they make our skeletons look primitive by comparison. If humans ever want to visit Kepler-22b, we'd need to become cyborgs essentially, powered exoskeletons that could support 6 times our normal weight. But even then our cardiovascular systems would struggle. Our hearts would have to work 6 times harder to pump blood upward. Biomedical engineers studying such extreme environments believe we'd probably need to completely reimagine the human body for such conditions. Perhaps genetic modifications that strengthen bone density, increase muscle mass, or even alter our circulatory system. We might need to become a different species entirely to survive there. The technology exists in early forms today. Military exoskeletons already help soldiers carry heavy loads. Medical devices assist people with mobility issues. Scale that up 6 times, add life support systems, and you begin to see the challenge we'd face. Here's something that might surprise you. Scientists believe Kepler-22b could be almost entirely covered by water. Not just oceans like Earth has, but a global ocean averaging 160 feet deep, covering the entire planet. Imagine a world where land is just a rumor, where islands might be as rare as finding a single tree in a vast desert. For any visitors from Earth, the first challenge wouldn't be breathing or walking. It would be finding somewhere solid to stand. But an ocean world isn't necessarily a barrier to complex life. In fact, it might be the perfect nursery. Water provides protection from radiation, helps regulate temperature, and offers a 3-dimensional environment where creatures can evolve in ways impossible on land. On Earth, some of our most intelligent creatures are marine dolphins, whales, octopi. An ocean world might be where intelligence truly flourishes. Imagine civilizations that build with coral, communicate through bioluminescence, or navigate by sensing electromagnetic fields in the water. And remember that crushing gravity we talked about? In water, it becomes much less of a problem. Creatures could grow to enormous sizes, supported by the buoyancy of their ocean home. We might find the largest organisms in the universe swimming in the global seas of Kepler. Think about the blue whale, the largest animal ever known to exist on Earth. It can only achieve such size because it lives in water. On Kepler-22b, with higher gravity but global oceans, evolution might have produced creatures that make blue whales look tiny by comparison. Of course, we're assuming these oceans are made of water as we know it. But what if they're not? What if the seas of Kepler-22b are filled with liquid methane, like the lakes on Saturn's moon Titan? Or what if they're rich with minerals that would be toxic to Earth life, but perfect for alien biochemistries? The possibilities are endless, and each variation would create entirely different evolutionary pressures, leading to life forms we can barely imagine. Kepler-22b was just the beginning. Since that first discovery, we've found thousands of exoplanets, each with their own unique story. And some of them are even more Earth-like than we dared to hope. Meet Kepler-22b, sometimes called Earth 2. This planet orbits a star so similar to our Sun that it's almost uncanny. The star is just slightly older, about 1.5 billion years, and a bit brighter. The planet receives only about 10% more energy than Earth does. What excites researchers about Kepler-22b is the time factor. This planet has been in its star's habitable zone for 6 billion years, much longer than Earth has been habitable. If life exists there, it's had a massive head start on evolution. Think about what that means. Life on Earth went from simple bacteria to complex organisms in about 3.5 billion years. With 6 billion years to work with, what might evolution have accomplished on Kepler-22b? Perhaps we'd find civilizations that have existed for millions of years, with technologies so advanced they seem like magic to us. Or maybe we'd discover that intelligence isn't the inevitable result of evolution, that despite all that extra time, life remains simple and beautiful in ways we haven't considered. But there's a catch, and it's a big one. In about 500 million years, Kepler-22b might experience what Venus went through, a runaway greenhouse effect that turns the planet into a hellish, uninhabitable world. If civilizations exist there, they're literally living on borrowed time. Then there's Kepler-1b6f, orbiting a red dwarf star much smaller and cooler than our Sun. This planet sits on the outer edge of its star's habitable zone, receiving only about 1/3 the energy that Earth gets. Standing on Kepler-1b6f at midday would feel like Earth about an hour before sunset, that beautiful golden light that photographers love. But here's the twist. Red dwarf stars are known for violent flares that can double their brightness in minutes. Imagine if our Sun suddenly became twice as bright without warning. On Earth it would be catastrophic. But Kepler-1b might be far enough away that these stellar tantrums are just dramatic sunrises. The planet has maintained a stable axial tilt for tens of millions of years, which is crucial for maintaining a consistent climate. An unstable tilt can have catastrophic consequences, transforming a potentially habitable planet into a barren world. Just look at what happened to Mars. Sometimes the best discoveries happen by accident. Kepler-1b 49c was initially dismissed as a false positive, just computer noise, nothing important. But when scientists took a second look, they found something remarkable: a planet almost exactly Earth size, receiving about 75% of the starlight we do. It's humbling to think how many discoveries we might have missed because our computers initially classified them as error. Kepler-1b 49c reminds us that the universe is full of surprises, and sometimes the most important findings are hiding in plain sight. This planet orbits its red dwarf star every 19 point, but despite this rapid orbit, the planet receives just the right amount of energy to potentially maintain liquid water on its surface. But perhaps the most incredible discovery of all is the TRAPPIST-1 system. Imagine 7 Earth-sized planets orbiting a single red dwarf star, with at least 3 of them potentially habitable. It's like finding an entire cosmic laboratory for studying how planets form and evolve. What makes TRAPPIST-1 so special is the resonance. These planets are locked in a gravitational dance, with their orbits perfectly synchronized. When the innermost planet completes 8 orbits, the next one completes exactly 5, and so on. It's cosmic clockwork. This system is only 40 light-years away, practically next door in cosmic terms. With future telescopes, we might actually be able to analyze the atmospheres of these worlds, detect water vapor, oxygen, even possible signs of life. Imagine if we discovered that multiple planets in the TRAPPIST-1 system harbor life. What would that tell us about how common life really is in the universe? If one stellar system can support multiple living worlds, then perhaps the galaxy is teeming with life in ways we never imagined. Think about what it would mean to have 7 planets in one system, some of which might host life. Would these worlds have evolved independently? Could life have spread from one planet to another through asteroid impacts, the way some scientists think life might have traveled between Earth and Mars? Picture this: a cosmic game of biological telephone, where life evolves on one world, spreads to its neighbors, and then evolves in completely different directions on each planet. We might find a system where every world tells a different chapter of the same evolutionary story. Of course, discovering these worlds and actually visiting them are 2 very different challenges. Even our fastest spacecraft would take millions of years to reach the nearest exoplanets. But that doesn't mean we're giving up. Scientists are working on revolutionary propulsion concepts that sound like science fiction, but might just become science fact. Engineers are exploring fusion ramjets that could theoretically reach 10–15% the speed of light. That's still a 40-year journey to reach Proxima Centauri, but it's feasible within a human lifetime. For the first time in history, interstellar travel isn't just a dream. It's an engineering problem we might actually solve. Picture spacecraft powered by controlled nuclear fusion, gathering interstellar hydrogen as fuel, accelerating continuously across the vast emptiness between stars. The technology seems impossible today, but then again so did powered flight just over a century ago. But even before we can travel there physically, we're developing incredible new telescopes that will let us study these worlds in unprecedented detail. The James Webb Space Telescope is just the beginning. Within the next decade, we might be able to create detailed atmospheric maps of nearby exoplanets, detect the chemical signatures of life, even potentially see weather patterns and seasonal changes on worlds dozens of light-years away. Imagine logging onto your computer and taking a virtual walk through an alien forest, or watching storm systems rage across the face of a distant super-Earth. We're on the verge of making these alien worlds feel real even if we can't yet touch them. Future telescopes might be able to detect the glow of alien cities, the geometric patterns of agriculture, even the chemical signatures of industrial pollution. We might discover that we're not just looking for life, We're looking for civilization. As we wrap up our journey tonight, I want you to consider something profound. Current data suggest that roughly half of all sun-like stars could host potentially habitable planets in our galaxy alone. That could mean billions of worlds where life might exist. And here's the really mind-blowing part. There's a 95% chance that at least one truly Earth-like planet exists within just 20 light-years of our solar system. 20 light-years. In cosmic terms, that's our backyard. We're entering an age where the question isn't whether life exists elsewhere in the universe, but how common it is, how diverse it might be, and whether we'll recognize it when we find it. Every new exoplanet discovery brings us closer to answering the ultimate question: are we alone? Think about what this means for humanity. For all of human history, we've looked up at the stars and wondered, soon, maybe within your lifetime, we might finally have an answer. What will it mean when we discover that first confirmed biosignature, that first radio signal from another world? How will it change us to know with certainty that we're not alone in this vast cosmos? The story of Kepler-22b and its cosmic siblings is really just beginning. Every day, new telescopes come online, new analysis techniques are developed, new worlds are discovered. Your children might grow up in a universe where we know of thousands of habitable worlds, where interstellar travel is being seriously planned, where the question isn't whether alien life exists, but which planet we should visit first. Consider this. In just the past decade, we've gone from knowing of no exoplanets to cataloging thousands. In the next decade, we might discover signs of life itself. In the decade after that, who knows, perhaps we'll be planning our first interstellar mission. The universe is vast, mysterious, and full of wonders we're only beginning to understand. And the most exciting part? This is just the start of humanity's greatest adventure, the search for our place in the cosmic community of worlds. So the next time you look up at the night sky, remember, you're not just looking at lights in the darkness, you're looking at neighbors, distant, mysterious neighbors, whose stories we're only beginning to tell. Somewhere out there, 265 light-years away, Kepler-22b spins silently in space. Perhaps in its terminator zone, under a sky of eternal twilight, something is looking back at us, wondering the same thing we are. Are we alone? The universe is calling. Are we ready to answer?